Lesson 1, similar triangles. So similar triangles are when they might be different sizes, but they're still similar to each other. So the corresponding sides are sides that match, and corresponding angles are angles that match. So if we look at the two following triangles, as you can see, angle A and angle A prime. Anytime you have a letter with a little dash at the top, that means prime. So because they are both right angles, angle A is equal to angle A prime. Should have put an angle sign there. Now angle B. So if you look at B, there's one line circling it. And on the other triangle, there's one line there. So a way that we show that angles are corresponding is we label them the same. So we label this with one line and the other one with two lines. Sometimes you put a little line through them. That shows that they're the same angle. So angle B is equal to angle B prime, and angle C is equal to angle C prime. Now if we were to name these triangles, if we were to call this triangle A, B, C, when you name the second triangle, you have to name the angles in the same order based on their matching angle. So angle A prime matches angle A, so A prime has to go first. B prime has to go second, and C prime has to go third. So the way in which you order things does matter. So make sure you always label them by the same corresponding angle. Now we're going to do corresponding sides. So from the right angle to the angle with one line, so from A to B, it's the same as A prime to B prime. B to C is the same as B prime C prime. And A to C is the same as A prime C prime. We can't write this C prime A prime because the order matters. So in a right triangle, meaning you have one 90-degree angle, and a 90-degree angle is always a square. You will know if angles are similar for two reasons. The first reason is that you'll have a matching angle aside from the right angle. So we know that angle P and angle P prime would have to be equal in order for this to be similar. And angle R and R prime would have to be similar. So anytime you have a set of corresponding angles, they'll be similar. So to test that, we have three different triangles. We want to see if they are similar. So in this first triangle, we know angle 20, and in this third triangle, we know angle 20 for that as well. So angle C is equal to angle I, and they're both equal to 20 degrees. That means since we know one of the sets of angles are equal, which means that this would also have to be equal, that they will be similar. So the way that we write this is we're going to name each triangle. So triangle A, B, C. And if we write the corresponding angles from this, so H, G, I, and therefore we know they are similar, put three little dots, and the symbol for similar is an upside down T. So because angle C equals angle I, therefore the triangles are similar. The second way that we can tell if triangles are similar is if we find a ratio of two of the sides to be the same. So what that means is we're going to take the smaller angle, or triangle, the sides, so let's go EF. If we look at the triangle, the corresponding side on the bigger triangle should be AC. So we want to see a ratio of those two. We also want to see a ratio of another side. So DF we also know, and on the bigger triangle that would be BC. So we want to see if both of these ratios simplify to be the same thing, and if they are, that means that they are proportional to each other, so they are similar. So EF is 4, and AC is 20, and DF is 2, and BC is 10. And if you simplify this, so if you type in 4 ABC 20, you should get 2R10. If you don't remember how to simplify fractions, always know that you can do it with the ABC button on your calculator. So 2 over 10 is equal to 2 over 10. So that means that they are in proportion and that they are similar. So we will write triangle ABC is similar, and we want to write the second triangle in the same way with corresponding sides, so triangle EDF. So that shows that ABC is similar to EDF. The Pythagorean theorem. So if we have a right triangle, that means that this angle is shown with a square, and if this is A, this is B, and this is C, actually let's make this C and this B, so ABC, whatever side is opposite your angle will be the lowercase letter of your big angle. So this will be A, and this will be lowercase b. And the angle that is opposite the square angle, so your right angle, is always the hypotenuse. And we call the other two sides legs. So there's two legs and a hypotenuse. So the Pythagorean theorem is this side squared plus this side squared and equal to your hypotenuse squared. It doesn't matter what letters you use, and it doesn't matter which order A and B go in, as long as your hypotenuse is on the right side by itself. So another way you could write it is leg squared plus leg squared equals hypotenuse squared. That way you can remember that the hypotenuse goes by itself and the other two sides are just the other two sides of the triangle. So in triangle BCD, determine the length of BD. So BD is our hypotenuse, and these are both a leg. So we're going to do leg squared plus leg squared equals hypotenuse squared. Our first leg is 5, our second leg is 7, and we don't know our hypotenuse. If you add 5 squared and 7 squared, so 25 plus 49, you should get 74, which is equal to h squared. Now to isolate h, to get it by itself, you take the square root of both sides, and you should get 8.6 centimeters is equal to h. I want you to always round to one decimal place. Maybe make a note of that on your page. So for the next triangle, triangle EFG, we want to find EF. So EF is one of our legs. This is a hypotenuse, this is another leg. So leg squared plus leg squared is equal to h squared. We don't know one of the legs. We do know the other leg to be 4 squared. And the hypotenuse is 12 squared. So now what we're going to do is we're going to isolate L right off the bat. So we're going to subtract 4 squared from both sides. So we should be left with L squared is equal to 12 squared minus 4 squared. When you simplify the right side, 144 minus 36 is 100, and by 36 I meant 16. I don't know why I said 36. Minus 16 is 128. Now to get L by itself, we take the root of both sides, so L should be equal to 11.3 centimeters.